Let's go ahead and start. We'll first take a look at linear equations, and we're going to spend the first hour and a half covering material, and then the last part of the will be to cover any questions you have. Let me word up here. Solving linear equations. We got a note that says at any step, combine like terms and combine numbers. Step 1, get rid of parentheses. And we'll do this via the distributive property. Step 2, get rid of fractions. And we'll multiply everything by the LCM of all the denominators, least common multiple. Step 3, get everything with an X on one side, numbers on the other side. I'm talking about terms, so get all the variable terms on one side, constant terms on the other. Step 4, divide both sides by the number in front of the X. That's coefficient. Okay. So let's take a look at an example. We got 3x minus 5 times x plus 4 equals 7. Step 1, get rid of parentheses. We do that via the distributive property, so I'm going to take the negative 5 and multiply it times the x and multiply it times the 4. Negative 5 times x is negative 5x. Negative 5 times 4 is negative 20, equals 7. Now you always combine like terms. Like terms where you have the same variable, the same power. So 3x minus 5x is negative 2x. Minus 20 equals 7. Step 2 is get rid of fractions. Don't have any. Step 3, get everything with x on one side, numbers on the other. So take negative 20 over. You take anything across your equals, your sign changes, so negative 20 becomes a positive 20. 7 plus 20 is 27. And then step 4, divide both sides by a number in front of your x. So divide both sides by negative 2. And we get x is equal to negative 27 over 2. Those negative 2's cancel. Now let's take a look going to the fraction. 1/5 x minus 1/2 x equals 3. Step 1, get rid of parentheses. We don't have any. Step 2, get rid of fractions. Multiply everything by the LCM of all the denominators. We got two denominators, 5 and 2, so our LCM would be 10. So we're going to multiply everything by 10. When I say everything, I'm talking about what's separated by pluses, minuses, and equals. Specifically in this problem, you can think of it as terms. Later on, we'll see we'll extend that idea, though, and it doesn't have to be a term. Okay, 10 times 1/5 is 10 over 5, or 2x, minus 10 times 1/2 is 10 over 2, or 5x, and 10 times 3 is 30. Now, you always combine like terms, no matter where you are in math. 2x minus 5x is negative 3x. I've specifically put it here just to really emphasize it, though. Step 3, get everything with x on one side, numbers on the other side. That's done. Step 4, divide both sides by number in front of your x. Number in front of x is a negative 3, so divide both sides by negative 3. 30 divided by negative 3 is negative 10, and that would be our answer. Now the second item here, identify the conditional equations, identities, and contradictions. Let me talk about that briefly. Okay, you work a problem down, and all of a sudden your x disappears that you're solving for, and you end up with something that can't be true, like 2 is equal to 3. At that point, when you come up with something that cannot be true, you come over here, and these are your 3 types. It's a contradiction. Some books call that no solution. And there's even some other names that they have for it. But it means there's no solution, there's no answer. Now, on the other hand, if I'm working a problem down, and all of a sudden my x disappears, I end up with something that's always true, like 4 is equal to 4. Well, this is our identity. When you come up with something that's always true, it's an identity. It means no matter what value you put in for the original x, it'll be true. Whether you put in x equals 1, x equals 7, whatever you come up with. Now, if I'm solving a problem down, I actually come up with an answer, like x equals 2. This is considered conditional. So again, first item, you come up with something that can't be, it's a contradiction. Then your second item, you come up with something that's always true, like 4 equals 4, 3 is equal to 3, or whatever. That's an identity. And then if you come up with an answer, it doesn't have to be exactly 1. You could have 2 answers, or however many. But if you come up with an answer, that's conditional. It means the original equation is conditionally true when, in this case, x is equal to 2. Now, next topic is rational equations. So let's talk about that. So solving rational equations. Step 1. Get rid of parentheses. Step 2. Get rid of fractions. Now our first substep within that says to factor all the denominators. Our second substep says to figure out the LCM of all the denominators and multiply everything by it. Step 3. Solve for x. And that's pretty vague, but it has to be vague. You'll either have a linear equation at that point, and you use the 4-step method we talked about, or you'll have a quadratic at that point, and you'll use the zero factor property. And then step 4, you semi-check your answer. Now I'm going to talk more about the zero factor property here shortly. That's in section 1.4. And you'll even see later on they have some problems down here where we're talking about solving rational equations. That's where you get into the more complex ones. And the only thing complex about it is you have to use the zero factor property at some point. Okay, so let's take a look at an example. We got 5 over x minus 2 minus 1 is equal to 7 over x plus 3. Step 1, get rid of parentheses. Don't have any. Step 2, get rid of fractions. I do have fractions. First sub-step says to factor all the denominators. Well, these are factored as much as they can be. So our second sub-step, figure out the LCM of all the denominators and multiply everything by it. Well, we'll start with our first factor. We'll start with the x minus 2. Now I'm looking for the greatest number of x minus 2's in a single denominator. There's 1 here, none here, so the greatest number of x minus 2's is 1. Then I go to my next factor, the x plus 3, and I'm looking for the greatest number of x plus 3's in a single denominator. There's none here, 1 here, so greatest number of x plus 3's is 1. Now this is what we're going to multiply everything by. So we're going to take 5 times x minus 2, take negative 1 times that, and then I'll take x minus 2 times x plus 3 times this fraction. Okay. These x minus 2's would cancel. These x plus 3's would cancel over here. And you notice that all your denominators are gone at this point. So you're left with 5 times x plus 3 minus 1 times x minus 2 x plus 3 equals 7 times x minus 2. I'll take this a little bit further, but I won't take it very far. I'm really just showing the first part of this problem to show how you eliminate the fraction. Okay, 5 times x is 5x, 5 times 3 is 15, minus 1, and then FOIL this. X times x is x squared, x times 3 is 3x, negative 2 times x is negative 2x, negative 2 times 3 is negative 6, equals 7x minus 14. So we've got 5x plus 15 minus 1. X squared, 3x minus 2x is 1x or x, minus 6, equals 7x minus 14. Negative 1 times x squared is negative x squared. Negative 1 times x is negative x. Negative 1 times negative 6 is positive 6, equals 7x minus 14. Always combine like terms. 5x minus x is 4x. 15 plus 6 is 21. Equals 7x minus 14. Now at this point, we got to step 3. We would solve, and this is a quadratic equation. Now what tells us it's a quadratic equation is we got an x squared. Anytime you have an x squared and no higher power, then that's a quadratic equation. Anyway, like I say, I'm not going to finish that problem, but we would take our answer we find and we plug it back in the original problem to semi-check it to make sure it doesn't cause any denominator to equal 0. Now let me make up a slightly harder problem just to show how to eliminate the denominators. Eliminate fractions and eliminate denominators. Okay, so I got negative 2 over x squared minus 1 equals 3 over x plus 1. Step 1, get rid of parentheses. Don't have any. Step 2, get rid of fractions. I do have fractions. And first sub-step says to factor all the denominators. Now x squared minus 1 is difference of 2 squares. The x plus 1 I can't do anything with. So this is negative 2 over x plus 1, x minus 1 equals 3 over x plus 1. Now 2b, figure out our LCM of all our denominators. So we'll start with our first factor, the x plus 1. We're looking for the greatest number of x plus 1's in a single denominator. There's 1 here, so the greatest number of x plus 1's in a single denominator is 1. Then I'll go to my next factor, the x minus 1. And I'm looking for the greatest number of x minus 1's in a single denominator. There's 1 here, none here, so we'd have 1. So this would be our LCM. And we'd multiply it times our first fraction. And we'll multiply it times the fraction on the right side. We'll do that. This x plus 1 cancels that. This x minus 1 cancels that. This x plus 1 cancels this x plus 1. And we're left with a negative 2 equals 3 times x minus 1. 3 times x is 3x. 3 times negative 1 is negative 3, distributive property. Now at this point, step 3, solve for x. This is a linear equation because we got x to the first power. So we want to get everything with x on one side, numbers on the other. So take negative 3, move it over. So I got negative 2 plus 3 is equal to 3x. Negative 2 plus 3 is 1. So we've got 1 is equal to 3x. Divide both sides by 3. And we're going to get x is equal to 1/3. Maybe. Remember I said you have to semi-check your answer. So you have to plug that back in the original equation. Make sure it doesn't cause the denominator to equal 0. 1/3 squared minus 1, I don't know what it is, but it's not 0. And over here, 1/3 plus 1, that's not 0. So this answer is okay. Let me grab a drink here. And erase that. Now our last topic in section 1.1 is solving a literal equation for a specified variable. Literal equation is another name for formula. So solving a formula for a variable. Step 1, get rid of parentheses. Then we do this via the distributive property. Step 2, get rid of fractions. Multiply everything by the LCM of all the denominators. Step 3, get everything with the variable we are solving for on one side, everything else on the other side. We're talking about terms here, but they don't have to be terms. You could have a radical expression in there. Step 4, if possible, factor out the variable we are solving for. You will have 2 or more of that variable. Then step 5, divide both sides by what is in front of / back of the variable we are solving for. Okay, so let me make up an example. We got a over b plus x equals c. And we're solving this for b. So when we get done, we want it to say b equals something. Step 1. Get rid of parentheses. We don't have any. Step 2, get rid of fractions. Multiply everything by the LCM of all your denominators. We only have one denominator, so that is our LCM, so we're going to multiply both sides by b plus x. Same over here. Now on this side, b plus x is cancel, and we got a. C times b is bc, c times x is cx. Put them both in alphabetical order. Step 3, get everything with the variable we're solving for on one side, everything else on the other side. We're solving for b as in Bill, so I'll take the cx and move it over. So everything with a b will be on the right side, and everything else will be on the other side. When you take anything across or equals, your sign changes. So the positive cx becomes a negative cx. Equals bc. Step 4, if possible, factor out the variable we're solving for. You'll have 2 or more of that variable. We only have one b over here. We'd have to have 2 b's for us to factor it out. Step 5, divide both sides by what is in front of / back of the variable we're solving for. We're solving for b, and there's a c after it, so I divide both sides by c. Now I do that, dc is going to cancel. You got b is equal to a minus cx over c. And that'd be your answer. Let me clear that off. And that's all that first section. I'm going to skip the second section. Those are word problems. And let's go down to complex numbers. For complex numbers, we have something called standard form, and that's where you got a plus bi. And you should always write your complex numbers in standard form, even if it doesn't say so. Now the a is our real part, and the bi is our imaginary part. Now if you're wondering, oh, what is an I? Our definition of I is whenever you have a square root of -1, that's what gives you an I. Even more than that, anytime you have an I inside of, or anytime you have a -1 inside of a radical with an even index, gives you an I. So if I'm trying to simplify a problem, square root of -18. If I do the prime factorization, that's -1 times 2 times 3 times 3. Now remember, the square root, we're looking for a pair of somethings. Here's a pair of 3s, so this pair of 3s is going to come out in front, and this -1 will come out in front as an I. So that gives us 3i square root of 2. Technically speaking, the I should be at the very end. That's what standard form says, but a lot of books will leave it in front just so you don't lose track of the I. Now for the most part, you treat I's just like variables. So if I'm trying to add two complex numbers, 3 plus 2i times, or plus 4 minus I, well, those parentheses aren't doing anything, and I can put the real parts together, 3 plus 4, and if I treat these like variables, I got 2i minus I. 3 plus 4 is 7, 2i minus I gives us 1i, or just I. So our answer will be 7 plus I. Now if we have subtraction, the first parentheses here isn't doing anything, so I can just drop it. But the second parentheses is doing something. Whenever you have a minus, a negative out in front of your parentheses, this is going to flip the sign of everything inside. So the positive 2 becomes a negative 2. The negative 5i becomes a positive 5i. Now combine the real parts, 7 minus 2 is 5, and combine the imaginary parts. Negative 4i plus 5i is 1i, or just I. Now when we get to multiplication, we have a note here, because we'll probably run across some I squareds. I squared, whenever you run across it, is equal to -1. If you're wondering how would you get that, if you go back to the original definition of I, you square both sides, you'll see why it's equal to -1. So let's take a look at 3 plus I times 2 plus 5i. Well, this is just like foiling. We're going to take the 3 here, multiply it times the 2, multiply it times the 5i. So that's 3 times 2. That's 3 times 5i. And here we'll take the I, multiply it times the 2, and times the 5i. So I got I times 2, and I got I times 5i. Three times 2 is 6. 3 times 5i is 15i. I times 2 is 2i. And I times 5i gives us 5i squared. Remember, we always simplify, combine like items, in this case i's. 15i plus 2i is 17i. And we set up above that I squared is equal to -1. So I'm going to replace the I squared with -1. Standard form means you can't have I squared and above. You just can't have I to the first power. So I got 6 plus 17i minus 5. 6 minus 5 is 1, so we got 1 plus 17i. And that'd be our answer. Now let's take a look at division. It's not exactly division like you might think of it. It looks like division, but our main goal is to put this in the standard form, which means we can't have i's in the denominator. When you have a single imaginary part down in your denominator, how you handle it is you multiply top and bottom by I. So we're going to have I times 3 plus I. And down here we have I times I, which is I squared. Now I times 3 is 3I, and I times I is I squared over I squared. Now we said earlier that we cannot have an I squared, but I squared is equal to negative 1. So we're going to have 3I plus negative 1 over negative 1. Now if I split these into real part and imaginary part, I'm going to have negative 1 over negative 1 plus 3I over negative 1. Negative negative gives us positive, and 3I divided by negative 1 is negative 3I. So our answer will be 1 minus 3I. And this is standard form. Standard form says you can't have an I in your denominator. Now if I have 5 over 2 plus I. Again, the problem is we can't have I in the denominator. So when you have a real part and imaginary part, what you do is you multiply top and bottom by the conjugate of the bottom. Now conjugate means the first part's the same, last part's the same, but the sign in the middle is different. So 2, 2, I, and then a positive here and a negative here. And whatever you multiply by the denominator, you have to multiply by the numerator. Now up on top, 5 times 2 is 10. 5 times negative I is negative 5I. Now down below, 2 times 2 is 4, and I times negative I is negative I squared. You notice on the bottom part, when you're multiplying conjugates together, all you have to do is multiply your first parts and your last parts. So we got 10 minus 5I over 4 minus, and I squared is negative 1. So that gives us 10 minus 5I over 4 plus 1. Which gives us 10 minus 5I over 5. Split these in two separate fractions. So we got 10 over 5 minus 5 over 5I, which is 2 minus I. And that's our answer. Look, I had 2 minus I before, but I guess not. Now let's look at powers of I. We got I at first, which is I. We got I squared, which is negative 1. I to the third is negative I. And I to the fourth is positive 1. So then, our I to the fifth will be I. I to the sixth will be negative 1. I to the seventh is negative I. And I to the eighth is positive 1. Then this pattern repeats. Well, if I wanted to find I to the 201st power, for example, I probably don't want to build a table out that far. So we're going to use a little trick. Since they repeat in groups of 4, we're going to divide our original power by 4. And this is old style division. So 4 goes into 25 times. 5 times 4 is 20. Subtract them. The 20 minus 20 drops away. We bring down to 1. 4 doesn't go into 1, so that's 0. 0 times 4 is 0. And if I subtract that, 1 minus 0 is 1. That's a remainder. So what we do is if we divide by 4, we rewrite this as I to the remainder. And we said our remainder is 1, so we got I to the first, or I is our answer. And that's complex numbers. Now let's talk about quadratic equations. Let me erase this. Quadratic means you got an x squared. And there's different ways we can solve a quadratic equation. And our first one is called a zero factor property. And it says if you got something times something else equal to 0, then you can set each factor equal to 0. Now that may sound pretty vague, but it really is that vague. As long as you have something times something else equal to 0, you can set each factor equal to 0. So if I got x squared minus 7x plus 10 equal to 0. Now the different books call this by different names. I like this name the best, the zero factor property, because it tells you exactly what to do. The title is the steps. So step 1 says get a 0 on one side. We have a 0 on one side. Step 2 says factor the other side. Well, this is a factor using the PSD. Factors is x minus 2 times x minus 5. Now what the zero factor property says, if you get 0 on one side, you factor the other side, you set each factor equal to 0. So I'll set x minus 2 equal to 0, and I'll set x minus 5 equal to 0, which gives us x equals 2 and x is equal to 5. And those would be our two answers. Now our second technique we're going to look at is the square root property. Square root property says if you got something squared equal to something else, then you drop your squared and you put a plus or minus square root around the other side. Now let's solve this problem using the square root property. Well, this says the entire left side has to be squared. So you can't have anything in front of it, can't have anything after. You just have to have something squared. Well, over here, if I take the -1, move it over. Remember, when you move anything across your equals, your sign changes. So I move that term over, it becomes a positive 1. 8 plus 1 is 9. And then if I divide both sides by 3, because I'm trying to get the part that's squared by itself, we get x squared is equal to 3. Now our square root property says we drop our squared and we put a plus or minus square root around the other side. So our answer to this problem will be x is equal to plus or minus 3. Let's take a look at another example. Want to solve this, and we're going to solve it using the square root property. So notice that the entire left side is squared. So that's in the right form. So we'll drop our squared, and we put a plus or minus square root around the other side. Now we need to handle the 12, and 12 is 2 times 2 times 3. Share my screen. There we go. Now we need, not that there's any bound right now, but we need a pair of somethings. Here's a pair of 2s, so they're going to come over as a single 2. Now our goal is to get the x by itself, so I'm going to take the -1 over. Becomes a positive 1. And then we'll divide both sides by 9. And we get 1 plus or minus 2 square root of 3 over 9. And that's our answer. Now let's take a look at completing a square. Our first step in completing a square is to divide everything by the number in front of the x squared. Step 2, take the number, the constant term, to the right side. Step 3, take the number before the x, the coefficient, multiply it by 1/2, square it, and then add to both sides. Step 4, use the square root property to solve for x. I forgot a step. My wife's trying to kill me with the heat in this house. Factor the left side. There we go. Then step 5, use the square root property to solve for x. I haven't tried outside. Maybe it's cool. Not great. Not hot, definitely. Okay, so let's look at a problem. I'm going to show the easiest type here. If you look at the YouTube videos I put out there, though, you'll see the medium and you'll see the hardest type. I just don't have time to show everything. Step 1, divide everything by the number in front of the x squared. There is no number in front of x squared. Step 2, take the number of the constant term to the right side. So I'll take the 1 and move it over. So I got x squared plus 6x equals -1. Step 3, take the number before your x, which is 6, and you do this over and aside. You multiply it times 1/2 and you square it. It's always times 1/2 and it's always squared. 6 times 1/2 is 3, so we got 3 squared, which gives us 9. And then we want to add that to both sides. So I got x squared plus 6x plus 9 equals -1 plus 9. So we got x squared plus 6x plus 9 is equal to 8. Step 4, back to the left side. This factors as x plus 3 squared. Now I'm not factoring genius or anything. It's just whatever number's right here, right for a squared, sign included is what always goes down here. So there is no factoring involved really. Step 5. We want to use the square root property to solve for x, so I drop my squared, and I put a plus or minus square root around the other side. Now you should always simplify your radicals before you go on, and square root of 8 is 2 times 2 times 2. Now we're looking for a pair of somethings. Here's a pair of 2's, so they're going to come out front as a single 2. So we got x plus 3 is equal to plus or minus 2 square root of 2. And take 3 over, and we got x is equal to -3 plus or minus 2 square root of 2. And that would be our answer. Let me clear this off, and then we'll look at the quadratic formula. Now, our quadratic formula is when it's of the form ax squared plus bx plus c equal to 0. And we got x is equal to -b plus or minus square root of b squared minus 4ac all over 2a. So if I look at x squared minus 7x plus 2 equal to 0, and I want to solve this using the quadratic formula. First off, it's got to be in the right form. Right form means it's a quadratic, of course, and you have 0 on the right side, which we do. So we want to identify our a, b, and c. A is going to be whatever numbers in front of your x squared, which is 1. B is going to be whatever numbers in front of your x, which is negative 7. And C is going to be a number at the end, which is 2. So then I'm going to go through and replace all my variables with sets of parentheses. Now I'm going to plug in what I identified. B is negative 7. A is 1. And C is 2. And then simplify. Negative negative gives us a positive 7, plus or minus. Negative 7 squared is 49, minus 4 times 1 times 2 is 8, all over 2. This gives us 7 plus or minus square root of 41 over 2. And I think 41 is prime. So that would be our answer. And the end of that section. Okay. Now we're down here to, I'm skipping over the 1.5, just in the interest of time. We're down at 1.6. Polynomial equations. Okay, let me clear this off. Let's say we have x to the third minus x squared minus 9x plus 9 equal to 0. Now this is a polynomial equation. We got 0 on this side, and then we got a polynomial over here. Now we're going to use the zero factor property to solve this, so there's nothing new here. Remember the zero factor property, you have to get 0 on one side, which we do. It's right here. We then want to factor the other side. Now this begins by using grouping. I group first two terms together, last two terms together. First two terms have an x squared, so I factor that out, and that gives me x minus 1. The last group has a negative 9. Because remember, if your first term is negative, you always factor out a negative. And that gives me x minus 1. Now our goal was to get these parentheses the same, which they are, so I can factor out an x minus 1 out in front. And that leaves us x squared minus 9. Now x squared minus 9 is the difference of two squares, two terms with a minus between it. And it factors as x plus 3 times x minus 3. Now the last section we looked at zero factor property, and we looked at problems that just had two factors. You can have 3, you can have 4, you can have however many in a problem. The only important part is you got 0 on one side and you factored the other side. Then you set each factor equal to 0. X minus 1 equal to 0, x plus 3 equal to 0, and x minus 3 equal to 0. This one I take negative 1 over, becomes a positive 1. Here I take 3 over, becomes a negative 3. And here I take negative 3 over and it becomes a positive 3. And those would be my 3 answers. Now it could be that you have to use a quadratic formula within this process. So if you can't factor it completely and you got a quadratic, you may have to use, like say, the formula. Now that's polynomial equations. Let's talk about, we already looked at rational equations up above. So let's take a look at radical equations. Let me clear this off. Okay, radical equations. Our first step says to get a radical by itself, on one side, but do not create a fraction. Step 2 is to raise both sides to a power equal to the index. Step 3, if you have more radicals, go back to step 1. Step 4 is solve for x. That's pretty vague, but you'll either have a linear equation at this point and use your 4-step method, or you'll have a quadratic and use the zero factor property. And then step 5, you have to check your answers. This process gives you the correct answers, but sometimes it gives you false answers, so you have to check them on this one. Now I'm going to work one problem quickly through, and then I'm going to show the setup on the second one, but not actually finish it. Here we got square root of 3x minus 1 is equal to 5. So our first step says get a radical by itself on one side. We have a radical by itself on one side. There's nothing in front of it, nothing after it. We just got square root. Step 2 is raise both sides to a power equal to the index. The index is whatever number is in the slot right here. And if there is no number there, then it's by default 2. So we're going to square both sides. So we got square root of 3x minus 1 squared is equal to 5 squared. Now the square root and second power cancel each other, so that gives us 3x minus 1 equals 5 squared, which is 25. Now step 3 says if you have more radicals, go back to step number 1. We don't have any more. Step 4 says solve for x. And this is a linear equation because we've got x to the first power. So get rid of parentheses, don't have any. Get rid of fractions, don't have any. Get everything with x on one side, numbers on the other. So I'll take negative 1 over. And that gives us 26. And then divide both sides by 3. And we end up with x is equal to 26 over 3, maybe. But if I plug that back in, 3 times 26 over 3 is 26, minus 1 is 25. Square root of 25 is 5, so it checks. Let's take a look at how to get a radical by itself. We got this problem here. And it's always the opposite operation that allows you to get it by itself. Although there are shortcuts you can use to get it by itself. I need to get this negative 2 over the other side. I could simply just move it to the other side. It becomes a positive 2. But for some reason, people will struggle with that on absolute value radical equations, so I'm going to show it. So I'm going to add 2 to both sides, the opposite operation. This is minus 2, so we're going to add 2. So then the negative 2 plus 2 cancels. 8 plus 2 is 10. Now here the opposite operation is division, because this is 5 times the square root. So we're going to divide both sides by 5. Then we get square root of x minus 1 is equal to 2. And then we would work it down from there. I'm not going to show the rest of those steps there. Now I didn't show the hardest type of radical equation here. If you watch YouTube videos, I got examples out there of the hardest type. Okay, now that was our radical equations. Now we're going to talk about equations with rational exponents. Let me grab a drink here. If I have x minus 2 to the 5/2 power equals 1. Rational exponent, that's fractional power. how we're going to do it is we're going to raise both sides to a power equal to the reciprocal of that power. So that's 5 over 2. Reciprocal means fraction flip, so we'll take both sides of the 2/5 power. But we notice before we raise both sides to a power, the number up on top in our numerator is odd. Odd number on top means no plus or minus. Doesn't make a whole lot of sense yet, but when we work with the next example, you'll see what I mean by that. 5's cancel, the 2's cancel, so all of a sudden I'm left with x minus 2. And 1 to any power is 1, so then I take negative 2 over, becomes a positive 2, and we get x is equal to 3. And that'd be our answer. Now on the other hand, if I have this here, now I want to get rid of that fractional power, that rational exponent, so I'll take both sides to a power equal to the reciprocal of it. So we're going to have x plus 3 to the 4/3 power raised to the 3/4, and same here, raised to 3/4. Except, before I raise both sides to a power, I notice that I have an even number on top. That means put a plus or minus. So that means I put a plus or minus on this side. 4's cancel, the 3's cancel. And we're left with x plus 3 is equal to plus or minus. Now I can put 16 to the 3/4 in my calculator. We want to be out of graph mode, so you do second enter if you're in graph mode. And we want to do 16 to the 3/4. The key to it is you do 16 caret. Anytime you have more than a single number or single variable in your exponent, you put parentheses on it. So beginning parentheses, 3 divided by 4, closing parentheses, and then press enter. And that gives us 8. Now I'm taking the 3 over, so we got x is equal to -3 plus or minus 8. In this case, if your radical disappears, assuming you had a radical, then you want to split this up into 2 separate pieces. Because what that plus or minus means is you got x equals -3 plus 8, and you got x equal to -3 minus 8. And that's going to give us 5. And this one here gives us -11. And both of those check. I just checked them. So those would be our answers. So that's your guideline on when do you put a plus or minus. Okay. Equations in quadratic form. So let's talk about that. That's the U substitution. Let me clear this off. Step 1. Let the middle part be equal to U, and the first part be equal to U squared. Step 2. Solve for U, whatever that means. Step 3. Plug U equals blank back in and solve for x. And again, that's pretty vague. This is probably one of the most vague processes there are in algebra. And this is specifically for equations quadratic in form. Example. 5x to the 4th minus 5x squared plus 6 equals 0. Step 1. Let the middle part be equal to U and first part be equal to U squared. So this will be U and this will be U squared. It never includes a number in front, the coefficient. So we're going to rewrite this as U squared minus 5U plus 6 equals 0. Now step 2 says solve for u. Well, this will factor using the PSD. Factors as u minus 2 times u minus 3. Now zero factor property. You get 0 on one side, you factor the other side, you set each factor equal to 0. So we got u minus 2 equal to 0 and u minus 3 equal to 0, which gives us 2 and gives us 3. Step 3. Plug u equals blank back in and solve for x. So whatever we said u is equal to right up here is what now we're going to plug back in. We said u is equal to x squared, so I'll put the x squared back in for the u. And this time, to solve for x, you could use the square root property. There's different methods you use at this point. But here we have something squared equal to something else. So square root property says you drop your squared, and you put a plus or minus square root on the other side. Drop your squared, put a plus or minus square root on the other side. And those would be our 4 answers. Grab a drink here. When can you use this method? If you can take your middle part, whatever's right here, excluding the number in front, raise to the second power and it gives you the first part. For example, x squared raised to the second power. When you raise one exponent to another exponent, you multiply them together. That gives us x to the fourth, which is our first part. That's when you can do it. Now some of them will look kind of bizarre. You may have x minus 5 square root of x plus 6. If I take my middle part, which is square root of x, raise it to the second power. Well, square root and second power cancel each other, so that'll give me x. That gives me my first part. So this is a u substitution problem on this one. Okay, let me clear that off. And that was equations in quadratic form. Now linear inequalities. Let's take a look at those. So solving linear inequalities. We got a note up at top. It says at any step, combine like terms and combine numbers. Step 1. Get rid of parentheses. We do that via the distributive property. Step 2. Get rid of fractions. We multiply everything by the LCM of all the denominators. Step 3. Get everything with an x on the left side, numbers on the right side. And step 4, divide both sides by the number in front of the x. We have a note here. It says if you multiply or divide both sides by a negative number, you flip the inequality symbol. Okay, let me make up an example. We got 7x minus 3 is less than 4x plus 2. Now our first step, get rid of parentheses, don't have any. Second step, get rid of fractions, don't have any. Third step is get everything with an x on one side, numbers on the other. So I'll take 4x, move it over. I'll take negative 3 and move it over. Remember, when you take anything across your inequality symbol, the sign changes. So the positive 4x becomes a negative 4x. The negative 3 becomes a positive 3. Always combine like terms. 7x minus 4x is 3x. Combine numbers. 2 plus 3 is 5. Step 4. Divide both sides by number in front of your x. Number in front of x is a 3, so divide both sides by 3. And we got x is less than 5/3. Now let's talk about some of the different forms you'll run across. Let's say I did come up with x is less than -3. This is our form. We have something called set builder notation. Which we put curly brackets, x with a vertical bar, then whatever our form was. Now that vertical bar reads such that. So the curly brackets are the set. So the set of all x values such that this is true. Now for our interval notation. It's a less than, so it's going to -infinity. Now infinities always have parentheses on them. Now this one is specifically a less than, not a less than or equal to, just a less than. Since there's no line underneath here, that means we put a parentheses on this. And then our graph. If you have the interval notation, a graph goes hand in hand with it. Parentheses on -3, parentheses on -3. And then you shade whichever way it's opening. It's opening left, so shade left. Let's take a look at another one. X is greater than or equal to 5. That's our form. Now our set builder notation. You put curly brackets around it, x with a vertical bar, and then whatever our answer was. Now our interval notation. It's a greater than, which means it's going to positive infinity. Now infinities always have parentheses on it. Specifically, it's a greater than or equal to. There's a line underneath. If there's a line underneath, that means you put a bracket. And then our graph. If you have interval notation, the graph goes hand in hand with it. So bracket on the 5, bracket on the 5. And then you shade whichever way it's opening. They're opening to the right, so shade to the right. And that'll be our graph. One more. 3 is less than x is less than or equal to 5. Now that's our form. Our set builder notation. You got curly brackets, x with a vertical bar, and then whatever our form was. Now our interval notation. Since it's between two numbers, we'll have 3, 5. Now specifically, this is a less than. There's no line underneath. That means there's parentheses on the 3. But over here, there's a line underneath the inequality. That line underneath means it includes it. So we put a bracket there. And then our graph. Parentheses on the 3, parentheses on the 3. Bracket on the 5, bracket on the 5. And you shade whichever way they're opening. They're both opening inward, so I shade inside. And that'd be our graph. Let me clear that off. And our next topic involves compound linear inequalities. So solving three-sided compound linear inequalities. Step 1. Get rid of parentheses. Step 2. Get rid of fractions. You do these same way. Distributive property, multiply everything by the LCM of all your denominators. Step 3. Get everything with an x in the middle. Numbers on the other two sides. And step 4, divide everything by the number in front of the x. And it still holds true that if you multiply or divide by a negative number, you have to flip your inequality symbols. Okay, 3 is less than or equal to 5x minus 1 is less than 9. Step 1, get rid of parentheses, don't have any. Step 2, get rid of fractions, don't have any. Step 3, get everything with an x in the middle, numbers on the other two sides, so I'll take this negative 1 over both of the other sides. Just like before, when we took anything across our inequality symbol, the sign changed, so this negative 1 becomes a positive 1. And over here, same thing. It's equivalent to adding 1 to all three sides. So we got 4 is less than or equal to 5x is less than 10. Now step 4. Divide all three sides by the number in front of your x. Number in front of x is 5, so divide all three sides by 5. Then we got 4/5 is less than or equal to x is less than 2. And that would be our answer. Okay. Absolute value equations. I'm going to actually get through it this time. Not sure if I've ever actually got through this in the past. Not that I covered every topic, but at least you get an exposure. Absolute value equations. That says if you got the absolute value of something is equal to something else. Then you drop the absolute value and set it equal to positive the other side. Drop the absolute value, set it equal to negative the other side. So for example, I have this. Now, key to using this is you have to have the absolute value by itself on the left side. If it's not, you have to use the same technique we use in the radical equations to get the equation radically by itself. Well, this is by itself. So what's inside of our absolute values are p, and the other side is our q. And then we just plug in our formula. Everywhere we have a p, we'll plug in x plus 3. And everywhere we have a q, we'll plug in 5. So I got x plus 3 is equal to 5, and x plus 3 is equal to negative 5. Now here I'll take 3 over. So we've got 5 minus 3, which gives us 2. And here I'll take the 3 over and got negative 5, negative 3, which gives us negative 8. Now let me just show the start of another problem where you have to get it by itself. Okay. We can't apply our property until you get the absolute value by itself on the left side. So here I'll do the opposite operation. I'm going to add 2 to both sides. Negative 2 plus 2 cancels. 4 plus 2 is 6. Now the opposite operation of this is division, because that's multiplication. That's 3 times the absolute value. So I divide both sides by 3. And we get the absolute value of x minus 7 is equal to 2. And then at this point, this is your p and this is your q, and you do the same thing as that previous problem. Again, the key to these is get the absolute value by itself on one side. On some problems, you may not do it, and you might get the correct answer, and you think, well, I don't need to do that. But I guarantee other ones you will not get the correct answer if you don't get the absolute value by itself. Okay. Absolute value inequalities. So absolute value inequalities. And we got 2 cases here. We got case 1. We got the absolute value of something is less than something else. Then you got to rewrite it as negative q is less than p is less than positive q. And we got case 2 where you got the absolute value of something is greater than something else. Then you're going to rewrite it as p is less than negative q. There's an or here. And p is greater than positive q. Okay, so if I have absolute value of x minus 8 is less than 3. Of course, the key to using these formulas, just like before, is you have to have the absolute value by itself on the left side. Nothing in front of it, nothing after it. Well, we have it by itself. Nothing in front of it, nothing after it. What's inside will be our p, and the other side will be our q. Our formula says we got negative q is less than p is less than positive q. So everywhere I have a p, I'll plug in x minus 8, and everywhere I have a q, I'll plug in 3. So I got negative 3 is less than x minus 8 is less than positive 3. Now this is a three-sided compound inequality, so we're trying to get the x by itself in the middle. So I'll take negative 8 and move it over to the other two sides. So I got negative 3 plus 8 is less than x is less than 3 plus 8. That gives us 5 is less than x is less than 11. And that's our answer. Now consider this problem. Wanting to solve it, and you might look over here at our different types and say, well, there is no greater than or equal to. How you handle it when you have the line underneath is if I have a line underneath here, I will also have line underneaths under these. So no book ever lists all 4 formulas. It's implied. If you have a line under in your problem, you have to put a line underneath in all the different forms for that case. Well, this one's already in the right form. The absolute value is by itself on the left side. So this is our p, and this is our q. And our formula says we got p is less than or equal to negative q, and here's an or, and p is greater than or equal to positive q. So everywhere I have a p, I'll plug in x plus 1, and everywhere I have a q, I'll plug in 4. So I got x plus 1 is less than or equal to negative 4. There's no or here. And then x plus 1 is greater than or equal to positive 4. And I want to solve for x, so I take the 1 over. And we got x is less than or equal to negative 5. Here I'll take the 1 over. And we got x is greater than or equal to positive 3. And there's an or between them. And that's actually the last material. So let me clear this off. Now I'll stop the video. And then answer any questions you have.